Good morning, students. Now we are entering to the next chapter, which is congruence of triangles. Up to now, we have learned properties of triangles in the previous chapter. Now, this is a new concept, which is congruence of triangles. So now it is the introduction. So before going to congruence of triangles, first you have to know two words which are similarity and congruence. First, you have to know the difference between the similarity and congruence. So what is meant by similarity? As all of you know that the meaning of similar means equal. Okay, similar means equal. But here there is a lot of difference between similarity and congruence. Similarity means, see the definition here, if two figures have same shape only, they are said to be similar figures. Only they should be in the same shape. Okay, they should have a same shape only. Okay, if two figures have same shape only, they are said to be similar figures. But the meaning of congruence is if two figures have exactly the same shape and as well as the size also. Size also should be same. Okay. As well as the shape, the size also should be same. Then only those figures are said to be congruent figures. Okay, otherwise they are only similar only. If they have same shape, they are similar only, not congruent. As well as the shape, size is also same. They are called as the congruent figures. And the congruence figures are denoted by the symbol which is called as this symbol. Okay, what is that symbol? Congruency means we have to show that with this symbol which is called like this, and we have to read it as congruent to. We have to read it as congruent to. On the upper side of equality symbol, you have to write a tilde symbol like this. This is called as the congruent to. Okay, so if two figures are same, we can write it as some triangle ABC is congruent to triangle DEF, like that we will write. Okay, this is a symbol for congruence. But similarity means or equality means only equality symbol you will use, but this is congruent. Okay. Similar means just we will show the tilde symbol only actually. This is called as the similar symbol. This is congruent symbol. Okay. So now see the some example figures to understand what is the similarity and congruence here. If you observe in the first figure, this is, all of you know that this is Giza pyramid, which is situated in the Egypt. Okay, and on the right side there is a model of this pyramid there. If you observe, these are looking like a same in shape. They are looking like same in shape, but this is a small model of this one. If you observe the shape of this one and this one, there is a lot of difference in between these two. Okay, it is having only just 1 feet or 1.5 feet height only, maybe, if it is like that. But it is hundreds of feet, hundreds of meters height will be there. There is a lot of difference, but shape is same here. So these type of figures are called similar figures only. They are only similar to see. Okay, but shape is different. So that's why these two figures are similar only, not congruent. Like that, if you observe a Taj Mahal, this is the model of the Taj Mahal and this is the actual one. Okay, but they are looking like same. Even though are looking like same, the shape is same, but the size is different. That's why these two are only similar to each other, not congruent. They are similar to each other only, not congruent. If we take two 1 rupee coins or 5 rupee coins or 10 rupees coins, anyone is there, all coins will be similar or equal in both shape and size also, both shape and size also. Okay, that's why two 1 rupees coins, if we take, they are congruent to each other, because if we overlap one over the other, both of them exactly coincide with each other. Okay, the backside figure will not be observed. Okay, if you take a real coin also, we cannot observe the backside 1 rupee coin. Only we think that only 1 rupee is there. So these two figures are called as the congruent figures. Like that, so same size of the 100 rupees notes, same size of the 200 rupees notes. These are all congruent figures. So if you observe and if you overlap one over them each other, they will exactly coincide each other. Backside 100 rupees note you cannot see. Okay, cannot observe. So these two are also congruent to each other. These two are also congruent to each other. So that's the main difference between the similarity and congruency. Similarity means they have only same shape, but congruence means they should have same shape as well as same size also. So that's the main difference between similarity and congruence. Okay, by using this a small definition, we will see some more definitions of congruent lines, line segments, congruent angles like this. Okay, so first one is congruence of line segments. Congruence of line segments means, so for a line, it has only a length. It is a one-dimensional figure. Line is nothing. Line or line segments are nothing but one-dimensional figure only. One dimension means only one measurement only we can take. That itself also only the length of the line segment. Only the length L only we can measure. Okay, if uh, both the line segments have same length, if both the line segments have same length or they have length in equal, then those two line segments are called as the congruent line segments. Two line segments are said to be congruent if they are of equal in length. Okay, because the variable of these two line segments is only length. No width will be there for any line segments or any line. Okay, that one you can tell that conversely, if two line segments are congruent to each other, already we can tell that they are of equal in length. They are of equal in length. If I move this line segment, both of them move exactly the same measurement. Observe here, because these two are congruent to each other, exactly equal to each other, we can move them like this. Okay, so these two are line segments are congruent, so they are of equal in length. Okay, next one, congruence of angles. Here, which one is variable here? Angle. Measure of the angle is should be same. If the measure of angle of the two given angles are same, then those two angles will be congruent angles. Okay, if I change this angle accordingly, the second angle also will change if they are congruent to each other. Okay, so observe here, by changing this, both of them are becoming 90 degrees, 125 degrees, 54 degrees. So like that, here 23 degrees. So both of them are congruent to each other because the measure of these both the angles are same. Both of them are congruent to each other, exactly equal to each other. Okay. So next, congruence of circles. For any two circles, to become as congruent to each other, the radius of the circle should be same. Both the radius or both the radii of the circle should be same, because if I observe the formulas of the circles, the perimeter or circumference of a circle formula will be 2 into pi into r, and the perimeter and the area of the circle will be pi into r square. here this 2 and pi are the constant terms only. The radius only is the variable term. Here also in the area also pi is the only the constant term. R is the radius which is variable. Okay, we can change this radius. So we observe in the both the formulas radius only the variable term. That means in any circle, if we change the variable value, both the circumference and area will be changed. Both the circumference and area will be changed. That's why to tell the congruency of the two circles, we are considering the radius only. Okay? If they have the same radii, we can tell that both the circles are congruent to each other. If I move this here already it is 2 centimeters of the radius, here also 2 centimeters. If I move this as 3 centimeters, both of them will change. Because both of them depends on the radius only. According to the formulas here. So if I change the radius to some 4 centimeters, both of them are changing their circumference as well as the area simultaneously. Okay. At the same time they are changing. If I change this to 3 centimeters, this also going to change, and both of them are changing with the same circumference with the same area also. That's why if two circles have same radius, those two circles will become as congruent to each other like this. Okay, so what is the variable you have to find first before going to tell the definition of the congruence of any object. First, which one is we have to change to become as congruent to each other. Okay, here the radius, here the angle. For line segments, the variable is length only because it is a one-dimensional figure which is having only one measurement. Okay, so if I take a square, in square also, if you observe the formulas of the square, so what is the perimeter of the square here? 4 times of the side, which is if we add all the sides, because in any square all the sides are equal. So side plus side plus side plus side, 4 times of the side, which is the perimeter, and area of the square will become as the side into side again. Okay, in both of the formulas, the variable is here s only. Okay, if I change the s value, both of them, the s value will change accordingly. Both of them will change their perimeter as well as the area. Okay, perimeter as well as the area in the equal dimensions. Okay, so if I change this side of this square like this, 4 1 2 3 4 4 units, automatically the area is also changing, which is 4 into 4 16 centimeters, both of them. Okay, and the perimeter will become as 4 into 4, which is that also will become as the 16. Okay, so if I change this to only 2 centimeters side, the area will change as 2 into 2 4 centimeters, 4 square centimeters. Here 1 2 3 4 4 centimeters, and the perimeter will become as 2 into 4 8 centimeters. 8 centimeters will be the perimeter. So like that, both of them will change according to the side of the square only. Okay, because side is the variable here. So both of them should have the same side to become congruent to each other. Okay, if we observe rectangles, like a square, rectangle also have sides here, but opposite sides only equal here. But in square, all the sides are equal. Here, opposite sides only equal. So both the length and breadth should be same in the given two rectangles to become as congruent. Because if you observe the formulas of a rectangle, the perimeter will become as 2 of L plus D. Okay. 2 times of L plus B, and the area will be length into breadth. In both the formulas, L and B, both of them should be changed to become as congruent to each other. So according to the formula, we can tell that which variable should be same to become as congruent to each other. Here, according to the formula, S is the variable, so both the squares S should be same. Then they will be equal. Here variables L and B. So in both the rectangles, both length and breadth should be same to become as congruent to each other. Okay. So in circles, radius is the variable. So to become as congruent, both the circles should have same radius. Here the measurement of the angle should be same to become as congruent angles. Here the length of these line segments should be same to become as congruent line segments. Okay, so these are the basic concepts. Now we are going to our actual concept, which is congruent triangles. Congruent triangles. So how we can define the given two triangles are congruent to each other. So which one are the variables in two given triangles we have to find out. So in any triangles, three sides and three angles will be there. In any triangle, three sides and three angles will be there. So all the three sides and all the three angles should be same in the both the triangles to become as congruent to each other. All the three sides and all the three angles of the both the given triangles should be same to become as congruent to each other. Okay, those six elements are called as those 6 points which are three sides and three angles are called as the 6 elements of the triangle. So two triangles are said to be congruent if all 6 elements of one triangle are equal to the corresponding 6 elements of the other. The word corresponding is very important here. Corresponding elements only should be equal. Okay, we should not take randomly. Okay, what is the corresponding, we will explain. So now here, that is three pairs of corresponding sides and three pairs of corresponding angles are equal. That is, then we can tell that triangle ABC is congruent to triangle DEF. Here what is the symbol? Already I told you, which is triangle ABC is congruent to triangle DEF. Have to read like this, congruent to. Instead of writing the word congruent to each time, just we will write this symbol. Triangle ABC is congruent to triangle DEF. When they will congruent to each other, if all the three sides of this triangle is equal to this triangle and if all the three angles of this triangle are equal to this triangle, then triangle ABC will be the congruent triangle of triangle DEF. Okay, in the above figures. So now we have to see what are the corresponding elements of both the triangles of to each other. So what are the corresponding sides here? If we observe which elements are equivalent to each other, we have to observe here. Here this is side AB. Here this is side D. Both of them having the same length. So now these two sides will become as the corresponding sides which have the same length. AB is corresponding to DE. And also you have to remember that you have to follow the order also. If you are starting from this vertex to read the name of this line segment, you should follow in this triangle also. You should start from this vertex only. So AB is corresponding to DE, like that you have. You should not tell that AB is corresponding to ED like that. You should not tell that, because starting from this vertex, you should start here also from this vertex. So AB is corresponding to DE. Now, if you observe DC and EF, both of them have the same length. So DC is corresponding to EF. DC is corresponding to EF. And if you observe CA, CA and FD are having the same length, which is 7 centimeters. So CA is corresponding to FD. CA is corresponding to FD. So here, according to sides, AB is equal to DE, BC is equal to EF, CA is equal to FD, and if you take the angles, angle A which is equal to angle D, both of them have 84 degrees only. Here angle B is equal to angle E. Since these two are have 51 degrees of the angle, and angle C is equal to angle F, these two have the angle which is 45 degrees. Okay, now angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. Okay, now so since these sides and these angles are equivalent to each other, we can tell that those are the corresponding sides and corresponding angles. So if AB is equal to D, we can write it as AB is corresponding to DE. The symbol which is having both sides, which is arrow like this, we have to read it as corresponding to. We have to read it as corresponding to. Okay. So now since AB is equal to DE, AB is corresponding to DE side. Since BC is equal to EF, BC is corresponding to EF. Since CA is equal to FD, CA is corresponding to FD. CA side segment, line segment or side CA is corresponding to side FD. And if you take angles, angle A is equal to angle D. So angle A is corresponding to angle D here to become as congruent to each other. Angle B is corresponding to angle E, and angle C is corresponding to angle F to become those two triangles as congruent to each other. Okay, so since the corresponding sides and corresponding angles are equal to each other, we can tell that triangle ABC is congruent to triangle DF. Triangle ABC is congruent to triangle DF. So like that we can conclude here. This we will write. Triangle ABC is congruent to triangle DF. Okay, this is the congruency of triangles. To become two triangles as congruent, all the three sides and all the three angles of one triangle should be equal to all the three sides and all the corresponding sides and corresponding angles of second triangle should be equal. Okay, but this is the generalized concept here, but there is no need to become all the, there is no need to measure all the sides and all the angles of the given two triangles to test that whether the given two triangles are congruent to each other. For that, we will learn four types of conditions of congruence of triangles. So, to measure all the sides and to measure all the angles, it is impossible for sometimes. Okay, it is impossible. Some of the times, practically, it is impossible. Okay, to measure the figures on the paper, it is possible, but to measure actual objects on the earth or anywhere, somewhere on the space, it is not possible to find out the actual distance by using the tape or anything and actual angles like that. Okay, so for that we will use some congruence conditions of triangles to find out whether the two objects, the given two objects are congruent to each other, are exactly equal in shape and size to each other or not, we will check. So to test whether the two given objects are congruent to each other or not, we will use four congruence conditions. Now we are going to learn those congruence conditions. So first one is, they are very easy to remember also. The first one is side congruence condition. The name itself tells that just we have to know the measures of the lengths of sides of the given objects. No need to measure the angles also. Okay. So what is the statement here? Two triangles are congruent if the three sides of one triangle are respectively equal to the three sides of the other triangle. Respectively means here what is this? Corresponding sides. Okay, whatever we learned in the definition of congruence, this respectively means corresponding sides. If the three sides of one triangle are respectively equal to the three sides of the other triangle, then those two triangles are congruent to each other. Here, what are the corresponding sides here? AB and DE. Because these two sides are equivalent to each other, which have 6 centimeters, and BC and EF, which are equal in size, which is 10 centimeters. So BC is corresponding to EF, and CA and FD are having the same measurement, which is 8 centimeters. So CA is corresponding to FD. So by the definition of side congruence condition, here both the triangles have same lengths of the sides. Because of the side congruence condition, you can conclude that triangle ABC is congruent to triangle DEF. Triangle ABC is congruent to triangle DEF. So like this we can write. Here no, we are not measuring any angles if you observe. Just we are depending upon the lengths of sides only. Lengths of three sides of this triangle and lengths of three sides of that triangle we are comparing. Since the corresponding sides are equivalent to each other, we are concluding that the given two triangles are congruent to each other. So this is the first one, which is side congruence condition. It's very easy to remember. The three sides of one triangle are exactly equal to the three sides of corresponding sides of second triangle, then those two triangles are said to be congruent to each other. So next one is side congruence condition. Here also the name itself suggests that if two sides and the including angle of one triangle, if any two sides and the including angle of those two sides are equivalent to the corresponding two sides and the equivalent angle of the another triangle, then those two triangles are called as congruent triangle. Here we are taking only measurements of two sides and the included angle. Okay, observe here the definition once again. Two triangles are congruent if the two sides and the included angle, underline this word which is included here. Included, it's very important. Included angle of one triangle are respectively equal to the two sides and the included angle of the other triangle. Okay, here we are taking two sides which are AB and BC only. Here we are not considering this CA. Okay, AB and BC, and the included angle means the angle which is in between these two sides only you have to take, which is angle B only you have to take. Now this is S, this is A, which is angle, and this is S. The two sides and the included angle of this triangle are equivalent to the corresponding these two sides and the corresponding this angle. Then these two triangles are congruent to each other by using the condition which is SAS. Okay, we should not take the angle somewhere here, angle A and angle C. Okay, only you should take the angle in between the given two sides only. The two sides and the included angle. Included means the angle which is in between these two sides only you have to take. Two sides and the included angle of this triangle is equivalent to the corresponding two sides and included angle of this triangle, then these two triangles are called as the congruent triangles. So now which one are the corresponding sides and angles are there here? So now AB is corresponding to DE, BC is corresponding to EF, and angle B is corresponding to angle A. So by the congruence condition of side angle side, the triangle ABC is congruent to triangle DF. Triangle ABC is congruent to triangle DF. So this is the second one. First one is that is telling about only the lengths of the sides only. First one is we are considering only the lengths of the sides. Here it you see side congruent. Here this here we are taking only two sides and the including angle only. Next third one which is angle side angle ASA congruence condition. Angle side angle congruence condition. Here also the name itself suggests that two angles and the included side here. The previous one two sides and the included angle. Middle we are taking the angle there. Here middle we are taking side. Both the sides we are taking two angles. Two angles on the included side of one triangle. Two angles on the included side of one triangle are equal to the corresponding two angles and two sides corresponding two angles and the included side of the second triangle, then those two triangles are congruent to each other. See the definition statement once again. Two triangles are congruent if the two angles and the included side of, here also observe here, included side, two angles and the included side of one triangle are respectively equal to, means correspondingly equal to the two angles and the included side of the other triangle, then those two are congruent to each other. Here which angles we are taking here? I am taking angle B here and angle C. Two angles and the included side is which one? This one only. You should not take other two sides because the side should be in between the given two angles only. Here they are taking the angles B and C. The side should be in between these two angles only. You should not take these two, any of these two sides. Okay, angle, this is angle, side, angle. So these angles and sides which are corresponding to this angle and this side and this angle equal, then those two triangles are congruent to each other. So now BC is corresponding to EF here, side, and angle A is corresponding to angle E here, angle, and angle C is corresponding to angle F here. Okay, so now angle side angle here, angle side angle are equal, so these two triangles are congruent to each other. So now up to these three conditions, they are explaining about any type of triangle. Okay, so but in the fourth one, exclusively this is for only for right angle triangles. Okay, first three conditions, side angle side angle, these three conditions belongs to, and they will explain about the any type of triangle only, but this fourth one exclusively for right angle triangles. Okay, two right angle triangles are congruent. The statement itself tells that two right angle triangles are congruent. Means they are already right angle triangle, means one of the angle is equal to 90 degrees. That is already given condition. So when they will congruent? If the hypotenuse and the one side of the first triangle, one side, any side we can take. So in the remaining two sides we can take any one of the side. Okay, so if the hypotenuse and one side of first triangle are respectively, only have to take respectively, means corresponding side only have to take respectively equal to the hypotenuse and one side of the second triangle, then they are congruent to each other. So here we are taking already this is equal and no need to prove this angle B is equal to angle because they are exactly equal to 90 degrees because these two are right angle triangles. Now we have to prove that only remaining this hypotenuse and this side, any one of these two sides you can take. I am taking this side. So AB, the corresponding side DE and CA and the corresponding side FD should be same. Okay, if we take the order as AC, DF should be same. Okay, so already this is equal. So now these two triangles are exactly equivalent to each other. Okay, if the corresponding sides AB and D, two sides here. Okay, RHS, how it is RHS? This is right angle, right angle equal. So now hypotenuse, if we take second one, which is the center one, which is hypotenuse. Hypotenuse should be same here because these two are 9 centimeters and 9 centimeters, both are equal only. Here both are 90 degrees only. And this is 6 centimeter and this is 6 centimeters, which have same sides. So now these two triangles are following RHS, right angle hypotenuse side congruence condition, to become as congruent to each other. Triangle ABC is congruent to triangle DEF. So if you observe here 1, 2, 3, 4, 5, 6, 7, here also 1, 2, 3, 4, 5, 6, 7, both of them are equal. If you consider this side also, we can tell that these two triangles are congruent to each other. Any side we can take, but only one side we can take. Okay, because you have to prove that only this hypotenuse and another side, this is already equal to right angle. Okay, if in any right angle triangle, if hypotenuse and any one of the side of this triangle is equal to the hypotenuse and any one of the side of this triangle, then these two triangles are said to be congruent to each other. It's very easy, okay, to remember also. The first one, all the three sides should be same, side, side, side. The second one, side, angle, side. Two sides and the included angle which is in between them should be equal to the two sides and the included angle of second triangle. Those two triangles also congruent to each other. And ASA means two angles and the included side of one triangle is equal to the corresponding two angles and the included side of the second triangle, then those two triangles are said to be congruent to each other. Now this is the last one, which is right angle, hypotenuse and any one of the side of a right angle triangle are equivalent to the corresponding right angle and hypotenuse and side of the another triangle, then those two triangles are said to be congruent to each other. So up to now we are concluding these conditions of congruence. In the next session we are going to solve the problems from the exercise. Good day to all of you.